Now we will explore the second graph, velocity time graph. So whenever you take time on x-axis, velocity on y-axis, then it's called VT graph, velocity time graph. So let us go in detail of velocity time graph. Let me take an example. So x-axis time in seconds, y-axis velocity in meters per second. Yeah, meters per second is unit of velocity. Now the times are taken 2, 4, 6, 8 imaginary time intervals, and the corresponding speeds I'm taking 0.1, 0.2, 0.3, 0.4. These are the speeds, or you can say velocity. These are the times. Now at 2 seconds of interval of 2 seconds of time, the speed of the body is 0.1. At 4 seconds of time, the body speed is 0.2. Now at 6 seconds, the body time is 0.3. Similarly, 8 it is 0.4 meters per second. Now once again, if you join the points without any doubt, you can say that it's a straight line passing through origin. Yeah, it's a straight line passing through origin. So whenever the line is straight in VT graph, what is the state of the body? What you want to say about the state of the body? In the previous example, ST graph, I told that the body is in uniform motion. When the body is in uniform motion, its speed constant. But if you see this graph here, the velocity is increasing uniformly. The velocity is increasing uniformly. That's why you get a straight line graph. Okay, when the velocity is increasing uniformly, you can say the change in velocity with respect to time is constant, right? So this graph says velocity increases uniformly, means change in velocity implies change in velocity is constant. Whenever change in velocity is constant, then change in velocity by time is what? Correct, it is acceleration. So it has uniform acceleration. Yes. So whenever you see this graph, you can tell that velocity increases uniformly, or you can say that the body is having uniform acceleration, means constant acceleration. Now your question is that how do we find the acceleration using this graph? So let me tell you. To find acceleration, the graph is giving two types of information for you. First thing is the number 1, state of the body. As I told earlier in ST graph, state of the body, this also gives state of the body, whether the body's velocity increasing or decreasing. Now second, it gives acceleration. And I told you, we are going to find acceleration of this graph. And how it is? It is possible by taking slope or gradient of the graph. So slope or gradient of VT graph gives acceleration. Same mathematical formula, y2 minus y1 by x2 minus x1. So take any on y-axis any 2 points as y1 and y2. So let me take 0.1 as y1, 0.2 as y2. You can take this is y1 and that is y2. It's your choice, but be careful. Corresponding thing you need to take x1, x2. So y1 corresponding to is x1, y2 corresponding thing is x2. That should be careful. So y2 minus y1, 0.2 minus 0.1 divided by x2 minus x1, 4 minus 2. 4 minus 2. So 0.1 divided by 4 minus 2, it is 0.1 by 2. So what is the answer? You are correct. It is 0.05 meters per second square. See the beauty of this graph. So This graph not only tells the state of the body, it gives the acceleration also, 0.05 meters per second square, right? So there is only possible slope. Now we have one more advantage. We can find the distance traveled by this body using VT graph. Distance traveled, or I can say displacement traveled. If we say V is speed, distance traveled. If V is velocity, displacement traveled, anything. So how do you find? This can be possible by area of the graph. Area of the graph. Now you ask me a question that how do you find this distance? Take an example. From t equal to 2 seconds to 6 seconds, what is the distance covered? To find distance from VT graph, let me take an example. Okay, from t equal to 2 seconds to 6 seconds, what is the distance covered? Let us solve. Implies t equals to 2 seconds to 6 seconds, distance we want. Okay, see the graph carefully. 2 seconds, let me put some labels for this. A, 6 seconds is B. So this is the line, this is the B, solid line, you see. Now 2 to 4 seconds says this is C, this is D. Now what happened? It is the area of ABCD. As I told you, distance traveled you can find by using area of the graph. And here area of the graph is nothing but ABCD, because I asked 2 to 6 seconds. So 2 to 6 seconds only we have taken. Now what is the area of the graph? How do we find? So for this, what we do, there are two ways I will tell you. First we take the simpler way. From D, you draw a line. Take that intersection point is E. Now this area ABCD divides into two areas. One is ABED rectangle. The other one is DEC triangle. Therefore, the area is nothing but sum of area of rectangle and triangle. So rectangle is ABED rectangle area plus area of CDE triangle equals to, okay, it's very simple. Rectangle area is what? If your length is the L is the length, B is the breadth of rectangle, the area is length into breadth. And here see, length, breadth, AD into AB. So AD into AB. This is the area of the rectangle. And triangle, what is the area of the triangle? Half into base into height. So half into base. DE is the base. DE is the base into height. This is the height, C. Now quickly substitute the values. AD value, see this is the AD value 0.1 into AB. AB 6 minus 2, 4. Guys, remember 6 minus 2, don't say 6. AB in a difference need to take 6 minus 2, 4. Okay, plus half into DE, 6 minus 2 again 4 into CE 0.3 minus 0.1, so this is 0.2. This is what the calculation. Now we need to solve to find the result. So let me do it here. What is the result? 0.1 into 4, 0.4 plus half into base, so 2, so this is 0.4. So the answer is 0.8 meters. That's the distance traveled by the body.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.